To find the mean of a set of numbers, we add together all the values and then divide by the number of values there are. And the range, that's the largest number minus the smallest number. For these ones down here, working with a mean, we want to be a bit more quicker than calculating the mean each time, because we've only got 4 marks here. We're in test conditions and we've got 6 questions we have to answer here. So if we calculate the mean in each of these scenarios, then that's going to be quite time consuming. We probably want to look for a smarter way of doing this. And for this, we can use some of the fundamentals of what a mean essentially is and consider what effects each of these have. But before we jump to that, you might be struggling with these ranges up here. So t is the time in minutes. T must be greater than 0. It can't be equal to 0. And t must be less than or equal to 20. So if the time was exactly 20 minutes, it would be within this section here, because it can't be within this section because it can't be equal to 20. It has to be greater than 20. We can't go as low as 0 within this range, theoretically. Now, for the purpose of these questions here, we actually are going to go as low as possible within the range. In fact, lower than possible. We're actually going to go for the number itself. But we have to consider this when we are doing the question, because it will have a knock-on effect in some circumstances, actually not in the circumstances of these questions. And to consider why we can do this, if we go down as low as possible, we go to 0.0001. Actually, we can go lower than that. We can put a few more zeros in there. And we can just keep going. We can keep adding more and more zeros. But it's infinitely small. It's just so close to 0. For the purpose of our calculation, we're going to call it 0. But of course, we have to bear in mind that it's not equal to 0. And in the case of going up to 20, that's fine because it can equal to 20. So we can set those as high as possible. Now, a frequency, that's just the number of r. So this means that there is one who was within this range here. We don't know what that is. That could be as low as 0, well, not equal to 0, but as high as 20. These 6, they're going to be within that range. Now, usually if we're doing an estimate for the mean, we'd assume that each of these are in the middle, because that gives us a reasonable estimate. Some of these are going to be higher than the midpoint, some are going to be lower than the midpoint, so it kind of balances out. But in this case here, we're looking for the absolute extremes. The mean could be less than 20 minutes. Now I'm going to put down a few numbers here, and instead of putting 20, I'm going to put 2. So the 2 is going to represent the 20. And I'm going to start with these 6. We want the mean to be as low as possible, so I'm going to set all 6 of these as low as possible in the range. I'm going to set them to 20. The mean of 3 2s, let's start with that. The average of 3 2s, we'd expect it to be 2, because it can't really be anything else. If we add these together and divide by 3, we get 6 divided by 3. That does give us 2. So the mean remains at 2. If we add more 2s, it doesn't matter how many 2s we add, the mean is still going to be 2. Because for every extra 2 we add, we're dividing by an extra number, and that kind of cancels out the effect of adding that 2. But if we add this one here, this frequency here, this 1, and we set that to 0, then this is essentially going to weigh the mean down. It's going to be lowering it down below 2, because we're not adding anything, but we're dividing by more. And we can see this in action. If we were to add all these up, and we were to divide these, then we would get something lower than 2. But we don't want to do these calculations, as I said before, because we only want to be quite quick. Now let's consider how much lower than the current mean that is. That's 2 below. So if I add a 4, I add one of these forces up here, then that's essentially going to balance out, because this one I haven't added anything, but this one I've added 4, and that's greater than the current mean. If I add both 4 and 0, the average of those is 2. So it turns out that this actually balances the mean, and I'd still get a mean of 2. And you could go ahead and calculate this if you wish to, just to verify that. But if I add more 4s, this is going to balance it beyond 2, sorry. This is going to go above the mean of 20. So in fact, it's impossible. We can't go less than 20 minutes. So this one must be false. We can use similar theory for the other ones. This time we want the mean to be as high as possible. So I'm going to set each of these as high as possible within their range. And again, I'm going to start with this middle category here. So if I put 6 4s, then the mean of those 6 4s is going to be 4. If I add a 20, because this time we're going as high as possible within the range, that's going to weigh the mean down. But 1 6 is going to counteract that effect. We have 3 6s, so that's going to pull it up even more. This one's true. We can get above 40 for this one. And then the final one about the means is that the mean could be less than 40. Now this is obvious at a glance really, because these 3 can be as low as 40. And then all the others are going to pull it down below 40. We've got 620s, and we've got a 0 down there. That is clearly going to weigh it down a lot below 4. So this one must be true. The ranges for this one is a little bit easier. The range can be more than 40. We just want the range to be as large as possible because we're dealing with more. We're looking for as much as possible. But I have to be a bit careful here and a bit selective with what I'm choosing. I want to have the lowest possible value and the highest possible value. And if I do 60 minus 0, that gives me a range of 60, which is more than 40. So that one's true. Range can be less than 40. Again, I want to be a bit selective, but I'm not going to choose the same ones this time. I'm going to pick the best case scenario for this one and have the mean as low as possible and have the range as low as possible. So this time I'm going to pick 20 and 40. And if I do 40 minus 20, that gives me a range of 20. So this one's true as well. It could be. This last one's false though, because we've established that the greatest possible range is 60. And in fact, thinking back to our original theory that we can't actually be equal to 0, we can't even have a range of 60. The range has to be less than 60, because this has to be something bigger than 0. So there's no chance of us getting bigger than 60 minutes. This one must be false.